Welcome to this tutorial on density of metals and liquids using VLABs. In this tutorial, we will learn to determine densities of metals and liquids. To follow this tutorial, you should be familiar with ChemCollective VLABs interface. If not, for relevant tutorials, please visit our website. Here I am using Mac OS version 10.10.5. ChemCollective VLABs version 2.1.0, Java version 8. Here I have opened a VLABs window. Click on File menu and select Load Homework option. Select Molarity and Density from the list. Double-click on Metals Density Problem from the submenu. Go to Problem Description in the Stockroom Explorer. Pause the video to read the problem and then resume again. Problem states that you have 3 unlabeled bottles with metallic powder. You need to identify the metals in the bottles. The metal densities are given in the problem description. We will use Archimedes Principle to find the densities of metals. An object, when immersed in water, will displace water. The displaced water will be equal to its volume. Different metals have different densities. Hence, different metals of the same weight have different volumes. A metal that is less dense will displace more water than a denser one. Switch to Workbench. Double-click on Metal 1, Metal 2, Metal 3 to add them to the workbench. Double-click on Water icon. Click on Glassware icon. Select Graduated Cylinders. From the submenu, select 25 ml graduated cylinder. We need 3 25 ml graduated cylinders for this experiment. Right-click on Graduated Cylinder. Context menu opens. Using Duplicate option, make 2 copies of the graduated cylinder. Drag and bring the graduated cylinders to the center of the workbench. Label the cylinders as 1, 2 and 3. Let us drag graduated cylinder 1 to the water tank. Notice that a red warning icon appears. This indicates that procedure is incorrect. Place the graduated cylinder 1 aside. The correct procedure is to drag water onto the graduated cylinder. Change the transfer mode to Precise Transfer using Tools menu. Type 10 in the Transfer Amount input bar. Click on Pour. 10 ml of water is transferred into the graduated cylinder 1. Likewise, transfer 10 ml of water into graduated cylinders 2 and 3. Move the water tank to a different place on the workbench. Click on Select Tools menu. From the list, select Scale. Drag the scale to a convenient position on the workbench. Again, click on Select Tools menu. From the list, select Weighing Board. We need 3 weighing boards for this experiment. We can also use shortcut keys to copy and paste. Click on Weighing Board. Use Ctrl+C to copy and Ctrl+V to paste. Drag and bring the weighing boards to the center of the workbench. Label the weighing boards as 1, 2 and 3. Place weighing board 1 over the scale. Click on Tear button on the scale. Drag metal 1 over to weighing board 1. Type 50 in the Transfer Amount input bar. Click on Pour. Place the bottle aside. Remove the weighing board from the scale. Place weighing board 1 over the graduated cylinder 1. Type 50 in the Transfer Amount input bar. Click on Pour. Observe the level of water in the graduated cylinder. It has risen by 5 ml. Keep the weighing board 1 aside. Now place weighing board 2 on the scale. Click on Tare button on the scale. Drag metal 2 over weighing board 2. Type 50 in the transfer amount input bar. Click on Pour. Place the bottle aside. Remove the weighing board 2 from the scale. Place weighing board 2 over the graduated cylinder 2. Type 50 in the transfer amount input bar. Click on Pour. Observe that the water level in the cylinder has risen by 4 ml. Keep the weighing board 2 aside. Similarly, weigh 50 grams of metal 3 using weighing board 3. Place weighing board 3 over the graduated cylinder. Type 50 in the transfer amount input bar. Click on Pour. Water level in the cylinder has risen by 2.5 ml. Keep the weighing board 3 aside. This slide shows the density calculations for the metals. Calculate the densities using the formula density is equal to mass by volume. Experimental density of metal 1 is 10, which corresponds to silver. Metal 2 is 12.2, which corresponds to rhodium. Metal 3 is 20, which corresponds to platinum. Repeat the above experiment with different metal weights, 30 grams and 40 grams. Tabulate and analyze your results. Let us proceed to the liquid density problem. Let us add a new workbench. Click on File and select New Workbench option. Click on the workbench. Go to File menu and select Load Homework option. Select Molarity and Density from the list. Double-click on Liquid Density Problem. Double-click on Problem Description in the Stockroom Explorer. Pause the video to read the problem statement. Resume after reading. The problem states that there are two compounds A1 and A2. One of the liquids is a preservative. Other liquid is not a preservative. The preservative has higher density. Our aim is to find the liquid containing preservative. For this, we need to measure densities of A1 and A2. Switch back to Workbench. Double-click on compounds A1 and A2 to add them to Workbench. Obtain a 100 ml volumetric flask from the glassware option. We need two 100 ml volumetric flasks for this experiment. We can make a copy using duplicate option. Drag and bring the flasks to the center of the workbench. Label the flasks as A1 and A2. We can rename by pressing F2. Click on Select Tools icon. Select Scale and add it to the workbench. Place the volumetric flask A1 on the scale. Click on Tare button. Transfer 100 ml of compound A1 to flask A1 by precise transfer mode. Note the mass from the scale. Scale reads 126 grams. Note this value. Place the flask A1 aside. Remove volumetric flask from the scale. Next, place flask A2 on the scale. Click on Tare. Pour 100 ml of compound A2. Scale reads 85 grams. Note this value. Experimental results are tabulated on this slide. Calculate densities using the formula density is equal to mass by volume. Observe that density of compound A1 is more than compound A2. Therefore, compound A1 contains the preservative. Let us summarize. In this tutorial, we have learned to measure densities of silver, rhodium and platinum using Archimedes Principle. Densities of liquids with unknown concentration. For the assignment, open Default Lab Setup window. You will find many stock solutions. Find density for a few solutions of your choice. The video at the following link summarizes the spoken tutorial project. Please download and watch it. The Spoken Tutorial project team conducts workshops using spoken tutorials and gives certificates on passing online tests. For more details, please write to us. Please post your timed queries in this forum. Spoken Tutorial project is funded by NMEICT MHRD Government of India. More information on this mission is available at this link. This tutorial is contributed by Snehalata Kaliappan and Madhuri Ganpati from IIT Bombay. Thank you for joining.